I'm Bill Wagner, and I'm here to talk about some of the recent things that we've been doing in C Sharp. Not all cutting edge C Sharp 13 things as Dustin and Mads did yesterday in their presentation, but some of the features that have been baking for a while. They've been in a few versions, and if you're not using them, you really should be adapting some of these today just to make your code base a little bit easier to read, keep a lot of things in place where you can look at it and understand what code is doing a little bit better, a little bit easier, and to slowly start integrating those. And if you're like me and you've been using C Sharp for a while, it's really, really easy to just get in these habits where all we do is we just keep doing the same thing because it's always worked. It's been working forever. And that's one of the things with C Sharp, where we have a very, very high bar for backwards compatibility. So anything that happens that, we've added new features to the language throughout all these different versions, everything that you knew from whenever you first started using C Sharp, that all still works. But we keep adding these features and we keep looking at things because we want you to be more productive and because we are building different programs than we did, when C Sharp was first invented. You just heard Scott and Matt talk about Aspire and containers and building cloud native things and so on, and Azure functions and all these. So we're doing different things than we did 20 years ago. So I'm going to look at 6 different things that we've been working on over the past several releases and talk about where you should be integrating those into your code base today. And also talk about how to do it in a way that isn't quite so disruptive, right? Because, we're all shipping projects, we're all shipping product or applications that we have to get delivered. So, you can't just sit there and stop and say, I'm just going to, take the next month and just upgrade my code base to use the latest language features, especially because it all works. So we're going to go over pattern matching, file scope namespaces, init required, some different things with properties and the story around properties. We're going to look at string literals and a lot of the things we're doing with strings. We're going to talk about records and collection expressions. Okay, so now let's start with pattern matching. Pattern matching is a way to declaratively write what we historically have written with if then else imperative statements or switch statements and things moving back and forth. And it's like, if you do this, do that, and, check this. And if this was true, and now we're inside another block and we have more ifs and so on. And pretty soon you end up with this, fireman's ladder in and out and things. And you've got to walk through each statement to figure out for multiple variables, well, what does it really mean? So now let's just look at some code. So I'm going to start with just play around with some patterns. I'm going to talk about the thing I've added right here in a little bit, but let's just say I wanted to write a Boolean function, and I wanted to write a NAND gate. So I'm going to make a NAND function, and that's going to take 2 bools, A and B. And if you look, okay, the compiler is using C# language to just build it, but I want to use pattern matching so I can see how those inputs map to an output. So I'm going to say I've got 2 inputs here. I've got A comma B. And if you look, okay, that once again, Copilot just wrote this for me. If both A and B are true, then the output of an AND gate is false. Otherwise, it's true. Now, if I want, I can expand this out. I can actually say, you know what, if it's true and false, well, then it's going to be true. And now you see I start to get some things here. I've got a green squiggle under my switch. And what it says for me, this is a warning from the compiler that says, you didn't handle all possible input values, right? I've got 2 Booleans, so there's 4 input values. I've only got 2 there. If I write the others in as well, and then it says, okay, now that goes away. I have handled all the possible inputs of this. 1 is false, the others are true. Now, what Copilot wrote for me originally is, it said, all right, so since these 3 are all the same, I can say, well, I just don't care. Anything here, and it should return true. Okay. Now, I can also put the comma there because we saw for pattern matching, there's times you might want to rearrange these. And another thing with pattern matching is if I were to take this and move this one up above, now you see I get an error. And the error I get is that this one will never be reachable. because up here, it's already been handled since that discard pattern says, oh, it's going to match anything. So it's already matched anything. So as I write the logic for a pattern, anytime I do this switch expression, there are two things that are always going to be true on it. First of all, if my switch arms don't match every possible input sequence, I'm going to get a warning and say that, it's possible that the inputs fall right through and you didn't match anything. And then the output is to throw an exception. And it's also true if I end up putting something in place in one of these patterns and it actually takes over everything for a later pattern, well, then I'm going to get an error that says, this pattern you've put down here is never going to be reached. And because it's never going to be reached, well, that code never executes. So we're going to tell you that's probably an error in your code. That kind of logic from the compiler helps make sure that your logic in terms of I've got these multiple inputs and here's what should happen, make sure that that's a little bit more correct. And if you look at and you read this either in this form or, in the full form, if I go back to that version, you can read this and see exactly what the output is based on the input. So a lot of times what we'll find is if you've got code in your code base that does any number of these multiple ifs, this, and nested ifs inside the else, you can look at that as there's probably 2 or 3 or 4 inputs, and maybe there's a pattern matching way to make that a little bit more clear as to what happens. And there's a tutorial on Learn that goes through and takes a rather large system and refactors all kinds of if then else logic into some patterns, and you can experiment with that yourself. Now the other one I'm going to add here is something that we've discovered by seeing some error reports where people using pattern matching are making, I'm going to say, a common mistake because a lot of people are making it. So we're going to address it in an upcoming build of Visual Studio. So if you look at this pattern, I'm saying, okay, if it's a number between 1 and 10, and I want to see if it's not a perfect square. So I've written a pattern that looks perfectly normal and says, all right, if number is not 4 or 9, it's not a perfect square. It's 1, 2, 3, 5, whatever else. So therefore, this should run, and if I pass it in 4, if I pass it in 9, it's going to return false. Otherwise, it should return true. But when you run this, you'll find that there's an interesting mistake in it. And it's one that we've seen in a number of code bases when we look at them. We've had error reports and questions on the docs as well. So if you look, it comes in here and it says, the only one it says is not a perfect square is 4. This logic says 9 is a perfect square. And the reason is when you start using patterns with and, not, and or, they bind in a certain order. And what this pattern actually does is that. So it says it's not 4 or it's 9. Right now, the compiler doesn't warn on this, but soon in an upcoming build, it's going to start issuing a warning if you don't have the parentheses here, because the 9 will never match. It's effectively been subsumed by the not 4. And what you really wanted here is you wanted something like this, where it's not 4 or 9. Now, obviously, you can add parentheses in your code anytime you're using and, not, nor in some of your patterns, and it can increase the clarity. The rules in the language are clear, is that not binds first, followed by and, followed by or, which is the same thing we do on the primary expressions, the exclamation point, the double ampersand, and the double vertical bars. But again, a good recommendation is if you start building those conjunctions and compound patterns, go ahead and add the parentheses anyway. It guarantees that your code's going to be correct, and the developers that follow you can read it and understand exactly what you're putting together. So again, pattern matching, really good way to just simplify your code and express the intent of what you were doing. And when the slides come out later, if you click on this link, then that will take you to the tutorial that walks through a good half-hour exercise on using pattern matching. Now, one of the things that we just like, just to make your code look a little bit better, is file scope namespaces. So that's just going to remove an entire level of nesting for you. So all you have here, and I'm using Visual Studio because we get some tool tips, and the IDE will do this for me. So if I have this particular file, come on, you. If I just put a semicolon there, if you watch what happened there, it removed the two curly braces and outdented everything in the file by one tab. I still have the light bulb. If I really hate this for some reason, I can convert it back. And then I get the screwdriver and I convert it back this way again. Now, we really like this just because it gives you that extra horizontal space, to talk about your code and to have it work, give you a little bit more space for your logic. And it just gets rid of a little bit of clutter. Now, this does introduce, white space diffs on every line in your file. So what we've been doing even on our team, as we've been converting code and starting to use this feature, is we go in and, when we make the PR that made some of these changes, we tell reviewers turn off white space diff, and then the diff will only show the added semicolon and the removed braces, for that particular change. And it makes the PR review easy, makes the code review easy, and then that comment stays. So if someone's going through history later, they don't suddenly get that wall of diffs, and they can actually see what's really going on. And again, this isn't a feature I would go through and sweep your code base for. When you're making changes, it's one of those things that just makes stuff look a little bit tidier. Okay, and you've got the analyzers and fixators that update it. If you want to update your entire solution, you could apply the same thing and just run it through your whole repository. And with that one PR, say hide white space diff, and then you can move on. Now, init and required are two new keywords, relatively new, that we have added into properties to make properties act more the way we really wanted them to all the way along for design. So let's look at some things with some properties in here. So if I were to take, let's see, we'll play with this one a little bit. I think we could probably pop one in here. So let's just make a new class where I'm going to say inside here, I'm going to have a public string property for a name, and might set it that way. So you can see Kathleen Dollard helped create some of these demos originally. So that's our public get set property. Well, now as a string, if I don't set this now and I don't give it any initial value, I now have a warning, because that warning says, you might not have set this, and you said it's a non-nullable value or non-nullable reference type. So it's supposed to be set either in a constructor or someplace. So, well, let's change this now. Well, we'll leave that as a set for the moment. But now let's just say this is required. So now what's going to happen is if any place else in the code, somebody creates a new object of this type and doesn't set this property in a property initializer, they'll now get a compiler warning. The compiler are saying that you didn't set this required property. But now, of course, by doing that, it's now has to be get set. We have to be able to set it anywhere. And I don't really want it changing over time. So now we have init. Now what init does is it creates effectively a read-only property. However, callers, when they construct an object of this type, they can then set the property, but only as part of an object initializer. So you can set the property once, but you can't set it again. You can't change it after it's been created. But you still get to use that convenience of the object initializer syntax to set the properties. So from there, you get to start, and you makes it more clear what your intent is. I intended this to act like a property. It should act like data. You should be able to set it using an object initializer, but nobody gets to change it afterward. And now that helps here in terms of now, even inside this class, because now it's an init property, if I were to write some other method here, and just take a string and we'll say it's new name, And if I were to try to implement that and say, well, I want to just say name equals new name, well, the compiler once again now is going to give me an error here. Even inside the class, it now says, nope, you said this was init only, so you cannot set it after in anything outside of a constructor. Okay, so what you've been able to do here now is with a property, you can now make it read only inside or outside the class. You can give calling code the ability to use object initializers by saying it's a required property and using init instead of making it truly read only and so on. And that makes it just easier to work with any of this code to express what your intent is on any of the data members in any classes you design. So again, we're trying to just make it easier to work with properties all the way along. Now, strings, as we start using JSON and data more and more and more, we have more different ways that we're dealing with string data, especially now with, you've seen binary formatters going away. Serialization using binary formats can be dangerous. There are security risks there. So JSON is now becoming more and more of a way that we transfer data back and forth, or strings in general using some other format. So let's look at what those features do. Now, since C# 1, we've had your basic strings that you can see on the screen here. We've got just quotes, backslashes for anything that would be an escape character, double backslashes if it's supposed to be supposed to have the backslash in it. It's got \n, which, well, it's not quite right on Windows. It would be character turn line feed and so on. We also have verbatim strings. So if you put the ampersand in front of it, well, then you can get rid of some of the escape characters. You notice I still need double quotes here around this one, but I can use only my single backslashes. Now, if you look at raw strings, are really a nice feature, especially with something like JSON. If you look at this JSON string, is all of the element names or field names are quoted strings. Those that happen to be string values, they also surrounded by quotes. To try to write this using an earlier format, you end up with a whole lot of double quotes everywhere, backslash quotes, or some, it's just very, very hard to read. So what raw string literals do is now if you start a string with 3 quotes or more, then the string starts on the next line and you end it with 3 quotes on the ending line, and whichever one matches, if I were to start it with 4, which is perfectly legal, if you notice Visual Studio automatically added a 4th on the closing one, they have to match. So, 4, 5, 6, whatever, as long as it is 3 or more. The reason it was done that way is it's possible you could have a string that contains 3 repeated quotes, and we didn't want to make that impossible. Then once you have that discussion, well, what about 4? What about 5? And pretty soon you reach this point where we're just not going to pick the number, but anything more than 3 starts it. And now the actual string output starts with this column here where you can see that Visual Studio has added the highlighter there. Legally, it starts on the starting character of the closing quote. White space here is ignored, and any of the white space from column 1 up to the underlining with these brackets is ignored. And that looks like raw string. Now, what we could do here, once we have these, we also now have interpolated string examples. So now, as you were trying to build strings, if you've ever used toString, historically you would have open curly brace 0, open curly brace 1, and so on, and then expressions at the end of it, and they get filled in the right order, and you've got to kind of parse back and forth between the length of the string and which argument is next. Interpolated strings allow you to just put an expression inside those curly braces inside the string. Starts with a $, or $, and the ampersand if you want to do verbatim. And then the expression inside those curly braces is replaced as part of constructing the string. Recently, we also added the ability that as long as you're inside the C# part, you could have new lines or any other spacing in there, and it just works. Okay, for something as simple as just a variable, it's not that commonly used, but you may end up with something where you've got a link query or something like that, and you could format that all the way up and down and make it look the way you want it to. And if you look, you can do that here with things, an interpolated string for JSON. So now I can have the interpolated values come in on the JSON string. And if you notice here, they're surrounded by double brackets. The reason they're surrounded by double brackets is JSON uses a single bracket for starting an object. So I need more than one bracket. So using the same trick we use for the triple quotes, if I have multiple $signs, it takes that many curly braces to start an interpolated expression. So since I have $signs, it takes 2 curly braces to start it, an expression, 2 curly braces to end it. So it's very easy with JSON. And the same rules apply for an interpolated JSON string or an interpolated raw string literal as apply for just a raw string literal in quotes. If I were to have 3 or 4 or $5 signs, it would be 3 or 4 or 5 repeated curly brace characters. And they parse from the inside. So if I were to accidentally have a typo here and there's a third curly brace at the close, the outside one becomes part of the text string. And you can see that in the way it's colored. Right, so combination of raw string literals, interpolated raw string literals, interpolated strings in general give us a lot more expressiveness in working with strings and converting objects into string data and back and forth. So that's what we're doing with strings. All right. Next, we come up to records. Now, there's a lot of really good things about records. Let's go over in to discuss those. So if I make a record, we get something like this customer record. Okay, now, given we only have half an hour, I'm not going to pop it into SharpLab. But if you go to sharplab.io and you put this in, what you'll see is that it generates a very large number of methods for you. It generates equals. It generates a toString. It generates get hash code. It generates not equal. It generates an overrides of equal. It generates a hidden copy constructor that will get used if you make a derived record from customer, like maybe it's a business customer or a retail customer. And all of that gets generated by saying it's a record. And what that does, the record keyword on either a class or a struct says that the primary purpose of this type is holding data. So I want the compiler to generate all the code correctly to do value-based equality and to treat this as a value-based type. Even though in the case of a class, it is a reference type, but everything in terms of equality is based on the values that it holds. Now, and when we put those together, well, then we get a record that has those extra methods. And another thing that happens with records or with structs is we now have the with keyword that now says, all right, if I had created a customer, and now if I want to modify something, make a non-destructive mutation, I say if I take whatever was in X, my first record, and now with, and then set any number of properties, it will be a copy of X with the new values for the properties set that I set in the with clause. And I could do more than one if I wanted to. I could say first name equals whatever, right? That's, I can set any or all of them. Okay. Works the same as it does for structs. And another big advantage of using the record declaration on a struct type. So if you think about how equality is implemented in a struct, the compiler and the runtime have to do some weird things to look at all the values, maybe use some reflection, maybe do some other comparisons and see, and that's going to slow it down. Whereas when you say it's a record struct, the compiler knows exactly what fields are part of that record, and it just generates the code for that record type because it already knows what the fields are. Okay, so that's adding records into your types. Primary constructors. We've seen this a little bit already in terms of a record. We have a primary constructor here, where at the end of the type name, we just introduce the properties that we want. Now, in the case of a record, that will create public properties for each of those values. So in a record, primary constructor parameters become public properties. Now, in the case of a non-record type, what will happen is those primary constructor parameters become parameters that are in scope throughout the declaration of the class. So you can use them in any of the methods in the class, just like any other parameter. So oftentimes, if you're doing something with dependency injection, you can pass the dependencies as primary constructor parameters, and they're automatically available everywhere in the class. You don't need to declare a separate field. Technically, the compiler generates one for you, and a closure and the implementation is not specified exactly, but that's what it does do, so that you can access those anywhere. And then finally, collection expressions, which you saw a little bit yesterday. So we'll go through those only somewhat briefly. And in that, anytime you're initializing a collection or creating a collection that you're going to pass to a method or what have you, if you see I've now got some tips underneath any of these declarations, it's going to say, you can use a collection expression instead. I don't have to declare new. I don't have to add that extra syntax to remember. Is it curly braces? What goes there? Array.empty, same thing can happen. There's a simplified collection expression for that. Anytime you want the empty collection, it's just open close bracket. If I want to do this with the byte array, I can do the same thing here. Where now, you see, I don't have to assign it to a variable or assign it to a collection type if write byte array, which is right down right there, takes an array of bytes. Okay, fine. Got an array of bytes. I can initialize lists. If you notice, I can also use the stack alloc if it's a date time. Excuse me, I can also use a stack alloc if I'm setting it to a span. Sorry, I misspoke there. So, and it will stack alloc the span if we want to put it into a span. Same thing here. We don't need to state that. So why are these last two significant? If you think about what's going on here, especially in this second one, I'm sending 3 bytes as a collection to this other method. I don't need to declare stack alloc if I use the collection expression, because the compiler will go, this is being used as the parameter to that method, as the argument to that method. I will allocate these 3 things on the stack and pass them right to it. So by using a collection expression, we've enabled the compiler to say, I know how I want to get this bits of data to that method. I'm going to do it in the most memory efficient and time efficient way possible. So in the case of where it's being assigned to a span, I can put it on the stack. It's just going to be then part of the span. In the case where I'm passing it to a method, it can be a stack alloc structure, and then that is just pointed to for the method call. So those things become faster. But you don't have to remember all that and think of how you're using it and jump through hoops to get there. If you just use the collection expression, the compiler will do it for you. Okay. And then finally, I'm just going to show one quick demo of this, is that you can use, see if I remember which file this one was in, but if you can use a, put it up there. No, I can't remember. Where we can put a tuple declaration as an alias. So I can say If I were to add a using, and I am not seeing that one right now, and I think we're actually out of time. But that is one of the ones that we can use with the using directives. You can say using and give it a tuple type equals name. I think it's the other way around, actually. Name equals tuple type. And then you can get this slow grow up story from I have some data, it's discrete values. I find I'm using these things together. It's a tuple, make it an alias, it's got a name, and then I can slowly replace that with a type. So, as you've probably heard several times today, if you don't have .NET 9, go ahead and get it. And places that are resources to get, C# guide is where we have all of our docs for C#, including what's new for a few versions back, including C# 13. GitHub.com, .NET C# Lang is where C# design happens. And GitHub.com slash .NET Roslyn is where the compiler development happens. So those are places where you would want to keep track of what's going on. If you want to participate in the community on building C#, talking about what the features are, looking at bugs, or any other feedback on anything else in there. And with that, I am going to say thank you.